Welcome to Study Loop.
41.24, we're told that a certain material has a molar mass of 20 grams per mole, a Fermi energy of 5 electron volts, and is bivalent. There's 2 valence electrons per atom. And so we want to calculate its density. So taking equation 41-9, we can find the number of conduction electrons per unit volume. So this is 16 square root of 2 pi over 3 times the mass of an electron times the Fermi energy divided by Planck's constant squared to the 3/2. Now, in evaluating this, you can just look up the numbers and put them in, but you can also multiply the numerator and denominator of this to get an MEC squared, which is, one of these things you just end up remembering because you come across them so much. My research doesn't have anything to do with atomic or solid state physics, and I remember these numbers. Anyway, so the sort of mass energy of an electron is 511 kilo electron volts, and Planck's constant times the speed of light is 1,240, I believe, electron volt nanometers. So if you were to rewrite this as MEC squared EF over HC squared, you can save yourself some having to go look things up, just because there are these numbers that are so common that you end up just remembering them if you do problems this way. So I don't really need this right now. I just explain what it is and how you use it for this. And we might want that space for something later. So we have 5.09 times 10 to the 28 of these conduction electrons per cubic meter. We've got the molar mass here, so we might as well figure out its molar density. Since that's more convenient. 8.4 times 10 to the 4th moles per cubic meter. Of, oh wait, no, I'm sorry, we don't need this molar mass yet. We'll use that. Because we have the molar mass, we want this in moles. This is just dividing it by the Avogadro constant. So this is for the electrons. So now the number density of the atoms, we have 2 electrons per atom. So the number of atoms will be half the number of electrons. So this will be 4.2 times 10 to the 4th moles per cubic meter. So the mass density is going to be the number of moles per cubic meter of atoms times the mass per mole of the atoms. And it wants this answer in grams per cubic centimeter. And in those units, it's 0.84. Sometimes it's convenient to express units or densities in grams per cubic centimeter because 1 gram per cubic centimeter approximately is the density of water, which can vary depending on what's dissolved in it and the temperature and stuff. But for practical purposes, water has a density of 1 gram per cubic centimeter. And since there's so much water everywhere, it's convenient to think of densities in terms of being fractions or multiples of it. And so this would float on water, for example, because it's less dense.